Imagine a future where the vastness of space isn't a distant frontier, but an extension of our world. A future where satellites, no bigger than a loaf of bread, form a digital nervous system around our planet, connecting the unconnected and monitoring its health in real time. Picture rockets launching not just once a year, but every single week, their journeys to orbit becoming as routine as an international flight. And consider a reality where space travel isn't just for a handful of elite astronauts, but a possibility for scientists and engineers. Well, stop imagining. That future isn't decades away. It's unfolding right now, powered by a profound revolution in space technology. This isn't science fiction, it's the new space age, and it's here. Let's start with the smallest heroes of this revolution. CubeSats. The name is literal. They're built in standardized 10-centimeter units, or U's, which can be stacked like cosmic Legos to create larger satellites. This standardization is key. It transforms satellite design from a bespoke, decade-long process into something that can be assembled in months in a university lab or a startup's workshop. And the cost? A paradigm shift. We're talking tens of thousands of dollars instead of hundreds of millions for a traditional satellite. This has completely democratized access to space. Universities, startups, even high school teams are now building and launching their own missions, often hitching a ride to orbit on rideshare programs. For example, Planet Labs uses a massive constellation of CubeSats to photograph Earth's entire landmass daily. This provides unprecedented, real-time data for monitoring deforestation, tracking agricultural yields, and responding to natural disasters. But their use goes far beyond imaging. CubeSats are testing new communication protocols, studying space weather to protect our infrastructure, and even venturing into deep space, acting as scouts for missions to the Moon and Mars. Of course, none of these satellites could get to orbit affordably without the second pillar of this revolution: reusable rockets. This is the ultimate game changer. For decades, space launch operated on a wasteful model. Imagine building a brand new jumbo jet, flying it once, and then ditching it in the ocean. That's what we did with rockets. Each launch meant burning hundreds of millions of dollars of hardware. Then came companies like SpaceX, who asked a simple, audacious question: why can't a rocket land itself? Their Falcon 9 does just that. After delivering its payload, the first stage booster reignites its engines, guides itself through the atmosphere using hypersonic grid fins, and performs a pinpoint landing. It can then be refurbished and launched again, sometimes in just a few weeks. This has slashed launch costs by nearly 90%, making space more accessible than ever. And SpaceX isn't alone. Companies like Blue Origin and Rocket Lab are also pushing the boundaries of reusability. The next leap is already on the horizon: fully and rapidly reusable spacecraft like Starship, designed to be reused within hours, like an airplane. This is the technology that will build our orbital infrastructure and finally make humanity a multiplanetary species. Finally, let's talk about what we can do once we're in space, which brings us to the third revolution: space manufacturing. Yes, building things in orbit. The unique environment of microgravity opens up possibilities impossible on Earth. Here, gravity causes defects and separation in complex materials. In orbit, we can produce ultra-pure materials with flawless structures. Take fiber optic cables. In space, we can manufacture a special type of fiber called Z-blan that is so perfectly clear it could make internet speeds hundreds of times faster. Then there's medicine. Bioprinting complex human tissues on Earth is incredibly difficult because delicate structures collapse under their own weight. In microgravity, we can print these intricate biological scaffolds, potentially revolutionizing drug testing and one day ending the organ transplant waiting list. NASA and private companies are already 3D printing tools on the ISS. But the ultimate vision is to build massive structures entirely in orbit. Imagine launching raw materials or even mining them from asteroids, and using robots and giant 3D printers to construct spacecraft, solar power stations, or habitats piece by piece. This bypasses the tyranny of the rocket fairing, allowing us to build on a truly cosmic scale. So, from tiny CubeSats creating a web of data around our planet, to reusable rockets providing an affordable highway to the stars, to orbital factories building the infrastructure of tomorrow, these three revolutions are not separate trends. They are interconnected, each one enabling the other, creating a powerful feedback loop of innovation. The new space age is here, and it's moving at an exponential pace. The next decade will redefine how we see our place in the universe. If this excites you, hit like, subscribe, and share, because the future of space is too amazing to keep to yourself.